You're about to hear why TerraFab isn't just another ambitious idea from Elon Musk. It's a potential revolution in how we design, build, and launch objects into space. Right now, every satellite, rover, or probe sent beyond Earth is assembled piece by piece on the ground, then carefully packaged and launched at immense cost. What if instead we could grow those structures right here, using raw materials like metals and ceramics, and print them with unprecedented precision? That's what TerraFab aims to do, and if it succeeds, it could transform spaceflight as we know it. Let me break down why this project stands out so much. First, asterisk, it solves one of the biggest bottlenecks in space exploration: mass efficiency. Launching even a small satellite costs millions because every kilogram counts. TerraFab's approach uses a form of additive manufacturing that builds objects directly from metal powders or ceramic precursors. This doesn't just save mass, it potentially eliminates the need for some parts altogether. Imagine a satellite where 80% of its structure is grown in one piece, not welded together later. That kind of efficiency could unlock entirely new mission profiles, longer missions, larger payloads, or even structures too big to launch otherwise. Second, asterisk, it's designed for Mars, and that changes everything. On the red planet, where gravity is weaker and resources like regolith, Martian soil, are abundant, TerraFab could one day build habitat, landing pads, or even entire infrastructure, using local materials. That's not science fiction anymore. NASA and private companies are already testing ways to 3D print with lunar or Martian soil. But what makes TerraFab different is its focus on high-performance metals and ceramics, which can withstand extreme temperatures and radiation. If you're going to live on Mars, you need structures that don't just survive, you need them to endure. Third, asterisk, it's pushing the boundaries of what additive manufacturing can do. Most 3D printing today is limited to plastics or basic metals. TerraFab isn't it's a high-precision, high-temperature system that can print complex geometries with materials like tungsten, aluminum, and advanced ceramics. It's materials essential for aerospace applications. Think about it. Satellites need to operate in extreme environments. Spacecraft need to shield against micrometeoroids or solar radiation. And structures on the Moon or Mars can't be weak or brittle. TerraFab aims to deliver exactly that level of performance with a manufacturing process that could one day be automated and scaled. But here's the question that lingers. Is this still just a concept, or are we close to seeing it in action? Musk has hinted at progress, recently mentioning significant advancements in the lab. If those claims hold up, TerraFab could go from a groundbreaking idea to a game changer within years. And if that happens, we're not just talking about just satellites or faster missions. We're talking about a new era where space infrastructure is built with Earth-like precision, cost, and scale right here on our planet. So ask yourself, are you ready for the day when entire space stations are printed in one piece? When Mars bases aren't assembled by astronauts, but grown from raw materials? But for now, drop a comment. Do you think this kind of technology will change how we explore space? Or is it still too early to tell? And if you found this breakdown helpful, don't forget to like and subscribe so you don't miss future updates on TerraFab or other cutting-edge space innovations. I'll see you in the next one.